So here itself, the list is going beyond 6, and we know that, so we can then definitely accept that the number of devices connected to internet are definitely more than 6 devices per person across the globe. So many devices are connected to internet. Many devices are the number of devices are increasing day by day as far as the connection to internet is considered. These devices, in terms of Internet of Things, we can now call them things. These things can be small in size. These things can be large in size. The thing can be a stationary thing, a movable thing, a thing which is powered, or it is a thing which is not powered. We'll come to the examples of such things. Then connectivity, whether a thing requires continuous connectivity or it is okay if it is connectivity is not continuous. It is a physical thing, or sometimes it is a thing which is logical also. So we are connected to the things, or the objects in the things are numerous, or there are numerous ways in which you can categorize them. So n number of things, as you can see in the picture also, they are connected to internet. So this Internet of Things, or object or a thing in Internet of Things, we need to have some capabilities with it. Now, as we are connecting it to internet, and we know basically that a particular object, as we have our own identity, as we have our own name, so a thing also need to have a unique identity. Now, Internet of Things, when we are making the thing part of Internet of Things, we need to give the thing a particular identity, particular name, through which the thing will be identified, or the thing will be connected to other things, or thing will be connected to internet. So we need to give the ability to sense, to ability to store the information. So this is to be done. So how to give the ability to sense or to ability to store the information? So definitely this depends on how we are connecting our thing to the external world. So sensors play important role when you want to connect a thing, a dumb thing, a physical thing, and want to make it intelligent. So ability to make the information available to external entities. When a thing wants to give information about itself to the external world, definitely it should have communication capability. It should have communication capability, it should have computation capability, it should have decision-making capability. So a thing, we want to convert this thing into a smart or intelligent thing. We want to give the thing a unique identity. We want to give the thing ability to communicate, ability to take decisions. So in this process of making a thing intelligent, we definitely have to study how it is done, or what is the architecture of Internet of Things. Now, if you see the connected world, I have few of the figures or statistics starting from 2012 to the recent statistics. In 2012 around, the number of phones or number of desktop or were capturing out of all the connected world maximum percentage. So more than 60% was the number of phones or number of desktop or the laptop PCs. The scenario changed in 2016, where now we had more number of cars as compared to more number of phones. And the scenario is still continuing, and now we can say that there are more number of things connected to internet, or IoT traffic is around 34%, while the number of phones connected are becoming 30%. So day by day we are seeing that, so in around 2012 or 2014, let's say, the common people at least, or even I would say academia, was also not knowing about the term IoT. I remember in 2014, Intel had called one industry academia meet, wherein they introduced the academia with the term Internet of Things. They had introduced Intel Galileo, which is one of the smart board used for basic IoT prototyping. So till 2014, many people in academia were not knowing about even, or so common people now know everything about IoT, or many of the people know about IoT, or at least have heard the word IoT. But in 2014, there were very few people. I remember, or I can say that when we started, yes, it is the Chetan Sharma Consulting, which gives definitely the things are going to be different in India. But this scenario which I am presenting here is the across the globe. So in 2014, we were taking one of the project IoT based application for agricultural development. So at that time, it was very difficult for me to explain to the expert people that IoT is a term related to electronics and communication. There were even the expert in the domain, in academia, in the domain of electronics and communication, were not ready to accept that IoT is a term related to electronics. But now the scenario is different. Now IoT has become a compulsory subject in most of the universities or most of the electronics and communication field. So the growth in the number of connected devices will come to the enablers which make the things possible. Okay. So I used to ask this question, one of the question, which is what is common among the following things when you see the number of pictures here in front of you. So if you try to correlate or find out something common between these things, definitely there's nothing common. There are few. There's animal, a person, a door, a chair, a TV, a fan. So there's nothing common as such, but the only thing common among all these things is each and everything of these pictures can become a thing in IoT. So you can connect your pet to Internet of Things by giving him a tag. You can connect your kid to IoT, or you can track your child using IoT. You can make the door open by using sensors and the connectivity. So everything out of this can become the common thing out of it is it can become a thing in IoT. Now, definitely the next question comes, why you need IoT, or what is the requirement of Internet of Things. So IoT definitely has many reasons, maybe for enabling new technologies or new knowledge, to save resources, to improve the productivity. Increased comfort is definitely one of the basic reasons for which every technology works. Protect health. So in last 2 years, we have seen that many applications are coming in the domain of healthcare, which are IoT based application. To enhance safety and security, for high confidence transport. IoT, which was a term only related to Internet of Things, now you can hear the terms like Internet of Vehicles or Internet of Multimedia Things, or even recently I came across a word which is Internet of Military Things. So definitely you must have heard the term Internet of Everything. So everywhere we have the term which is the things again are getting customized, or we can say for every application we have a new term coined. So vehicle to vehicle communication or Internet of Vehicles is again an upcoming field where every vehicle can communicate with another vehicle, or vehicles can communicate with infrastructure, and we have many opportunities to work in this field. So preventing failure. So industrial Internet of Things is again one of the field where you have many applications for preventive or prescriptive maintenance. So there are a number of application areas where if you just see the top 10 IoT areas in 2020, definitely again here also there are many ways by which these areas are categorized, or there are many searches through which you can find the analysis. But we can definitely say that the mobility or transportation is taking an important share in IoT application. Same is the case with energy as well as retail industry. There are a number of applications in retail industry, smart cities, and it is building up, or few of the applications are coming in the agriculture domain with the vertical farming or hydroponics coming into picture, or called as the controlled environment agriculture. So there are many areas where IoT is making the impact. Smart home is again one of the application where there are n number of apps coming for smart home. Then wearable is again a technology where we have many applications. So n number of sensors getting connected to internet, making the network and helping us to improve the quality of life. So as we discussed, all these are the applications where internet is used. So waste management in case of smart city is one of the again example which is definitely a need in country like India, where we must focus on separation of the wet and the dry garbage, then overall maintenance. Or so one more question which again I have at this point is, so one of our very basic starting point for IoT based application, which wherein people came to know about IoT was. So can we have the third poll here? Yes, I think there's already the answer given in the chat window. So what is the sensor used in FASTag? So FASTag, now each and everyone, as it is made compulsory, each and everyone knows about. I guess we already have the answer given by somebody in the chat window. And the sensor which is used in FASTag is RFID. So RFID is one of the basic identifier which was used, or which was one of the starting point in the retail industry for which we can say that used for IoT. So radio frequency identification, nowadays called as NFC or near field communication tag, which we have many categories of this RFID sensors. RFID sensor can be active or passive. Most of the sensors which we see are passive, but it's difficult to believe that this RFID sensor is an electronic device. It has got processor, it has got an antenna. You can save the information about the particular object in this small electronic device. So yes, RFID is the answer of the sensor which is used in the FASTag. There are many applications in Agri IoT, as we discussed. We can use IoT for checking, for field monitoring. It was the basic application, because just sensing the soil moisture and switching on the irrigation system was the basic application for which it was used. So remote monitoring of the agricultural or the farm pump which was watering the farm. But further it was used for measuring the diagnosis of diseases. It was used for auto spreading or crop yield analysis, because a lot of data was generated with the sensors which were embedded into the agriculture application. Still, this, in order that this becomes a reality or it becomes to a farmer in real sense, we have few more years to go in India. But in developed countries, this has become a regular practice of using the quadcopters or drones for many of the applications in agriculture, or using the controlled environment agriculture, wherein every parameter is measured by the sensors. It is processed, it is analyzed, and the decisions are taken depending on the parameters. So in case of IoT in healthcare also, there are n number of applications. Like initially you can divide them as services and then the application. So under services, you need not know the details of, need not be a doctor or need not be a expert in healthcare, but still you can help in the medical domain, like ambient assisted living, then internet of medical health or drug reaction or community healthcare, wearable device access, or then in the applications, the glucose level measuring or ECG monitoring, body temperature monitoring. So nowadays, even a smartwatch which we have, it helps us measuring many of the body parameters. So many applications are there in the domain of IoT in healthcare also. Retail industry, as I said, RFID is one of the basic starting point for IoT based applications. So the many of these things can be given with RFID tag, and it becomes very easy to track the things in retail industry, or tracking of the objects become easy in the retail industry. So by use of RFID tags. Then smart grid is again one of the application wherein lot of scope is there for IoT. Lot many sensors are used to manage the power. Then there are BLE based or RFID based many applications in tracking. And then there are applications in manufacturing. Now, what is enabling all these things? So basic reason or basic thing which help us doing it is definitely the growth in the technology. The growth in the technology, which is there in as far as the microcontrollers are considered. Earlier, we had only 8-bit microcontrollers, then 16-bit microcontrollers. And now we know that the microcontrollers, the development in microcontroller has reached to even smaller edge devices. So we, at least everyone has experienced the growth in your smartphones which you have in your hand. The controller used in the smartphone is getting developed day by day, and we are getting the benefit out of it. Then the flash storage also is improving. The n number of communication systems are coming into picture. Earlier, you must have experienced that while using Bluetooth, our battery used to drain very early. But now the Bluetooth is changed to Bluetooth low energy, and we can see that we can use Bluetooth for many of the applications, and the battery is still there. So radio communication, many of the protocols are coming into picture, and definitely because of that, the IoT applications are enabled. There are n number of sensors, active sensors, smart sensors, you may call them, and these are getting developed day by day, and everything is integrated together and connected to networks. So this is what is enabling the IoT applications. So key enablers, if you say in the field of IoT, are the chip silicon SoCs, or we can say the chips which are used for development of the IoT prototypes, the mature internet protocols, the cellular connectivity. Earlier, the connectivity was for by the use of people. Now, taking into consideration the traffic on the IoT connectivity, there are n number of protocols which are coming into picture, which are going to help you to solve the problem. There are unlicensed band where you need not pay for the connectivity and you can develop your own application. Then number of ways by which the data generated out of this IoT application is analyzed. N number of application or APIs are coming into picture, and the cloud infrastructure available with us are. So all these are the key enablers which are helping us to develop the IoT application. So in a simple way, if I want to define IoT or IoT elements, so IoT can be said it is equal to first identification, a simple RFID tag, or even now a QR code also helps us in this regard. So simple RFID tag can be one of the basic identifier or one of the basic name given to a particular device. So as I said, initially we need to give identity to, and that identity need to be unique. So if in a warehouse I have n number of chairs, every chair will be given a unique identity so that I can track where this particular chair is coming from or where it is supposed to be delivered. So unique identity can be given by a RFID tag. Then if you cannot give a tag, another thing possible can be a sensor. Like in agriculture application, will not be able to give tag because we want to sense the application. So for sensing, let's say I can use a soil moisture sensor. So this soil moisture sensor will help me in getting the physical condition of the soil, which will become my sensor. So either identifier or sensor. In few cases, you may need an identifier, you may need a sensor. Then communication capability. We'll come to how this communication is developed further. Then some computation. You have to take some decision. You cannot send each and everything on internet or to the cloud. So there are some platforms for processing the data, then few services to take care of this, and then we need semantics or some brain, some intelligence to come into picture. So these are 6 main or 5 main, we can say these two are either of these two is to be there. So these are 5 main components which are helping us in developing the IoT application. So we can now say the components of IoT. So first out of that is definitely the number of things, either living, non-living, movable, not movable. These things, they need to, or if they have sensing capability, they can sense and give the data to the device or edge device, or we call it aggregator or a processor, which is going to process it further. So in order to connect these devices to the aggregator, which is going to aggregate the data coming out of many sensors and then send it to using a remote connectivity to a cloud or to a touch point. So there is initially requirement of local connectivity, then there is requirement of remote connectivity, and then you need few touch points from where you can access it. So sending the data, it says sending the data related to the soil moisture. You need a sensor here. The sensor will read the data. So only reading the data is not sufficient. While reading the data also, you need a controller which will help you to take the data at a particular point. Then you need a communication system using which you will convey this information to a end device or edge device, and through the edge device it can be given to the cloud, and the user will access the data from the cloud through an application. The user can access the data which is sent to cloud. So cloud-based infrastructure or cloud-based architecture to which will be coming is the basic architecture which is used for IoT. So these are the basic components. Now, before going to the architecture, let's first go into what are some structural aspects of IoT, depending on which you have to go for the design or you have to go for the architecture of it. So first and the most important point while designing IoT application is low power. Because almost all the applications, almost all the devices or we can say many of the applications, they need, or they are movable, or they are battery operated, or at least we can say that they are not always connected to the electricity. So the application must be low power. While designing the IoT application, first thing is to take care of the power requirement even if you take example of your simple mobile phone, the first thing which you would like to know is at least the battery of your mobile phone should last for a complete day. If it is not lasting for a complete day, definitely you won't prefer the particular mobile phone, even if it has got many of the features. So power requirement is the basic design constraint, because just the basic reason, because most of the devices are battery operated. We are not assuming the devices here as stationary devices. So if the device is stationary, if it is always connected to the electricity, then you may think of. So low cost, so it is always desirable as we are going for mass production, or we want it to reach to common people. The cost of the device or cost of the system developed has to be minimum. One of the very important parameter in IoT application is there are significantly more devices, severely limited code and the RAM space. These devices, definitely, as we have seen, these devices, they need some computation, they need some communication capability. But when I say a mobile device, they have limited computation capability. You cannot expect a parallel computer to be there with them. So limited code and RAM space, this needs, then it comes to the application, like if it has got operating system, it must be light OS, or if it the algorithm should be minimized, or the data size. All these things are to be taken into account. So requirement for simple wireless communication technology. So these are the basic design constraints depending on which you can go to the architecture of IoT. So low power, low cost, considering the scalability, we'll come to scalability next. Limited, or it is called as constrained environment. The device must be able to operate in the constrained environment. Limited code and a RAM space, and the limited bandwidth. So as I said, scalability is one of the basic term in IoT application. So scalability you can define as capability of a system to manage an increasing quantity of the. So without adding extra resources, you must be able to add more number of devices, or your system should work even if few of the devices are removed from the system, or few of the devices getting added to the system. So like if you say it is a application of smart city, initially, let's say, let's take an example of a parking system. Let's say I'm designing a parking system. Initially, let's say I'm designing it only for my MIT campus. Then by seeing the success of this parking system design, maybe I should be able to scale it to the Kothrude region. Further, if it is successful in Kothrude region, I may expand it to complete Pune region. So parking is the main issue in Pune city, or we can say there's a lot of roadside parking, and whether I'll be able to get a parking space when I reach a particular place in Pune is definitely a question which comes to the mind. So before a few years, we had taken up this as one of the problem to solve. So when it is in the controlled environment, there are solutions available. But when it is the roadside parking, which is one of the major concern in Pune city, so you need to find out the solution, how this parking space can be connected to internet, and will it be possible for us to, let's say, find well in advance whether a particular I'll be able to get a parking space or not, or will it be possible for me to reserve a parking space for me. So in this way, whatever solution you provide, initially you need to, as it is said, start small and then build out, or then go on increasing the size. But while building the small part, I have to think of the big picture. I have to think like whether I'll be able to expand or scale my solution, which is done for a smaller area. So addressing communication or service discovery are delivered efficiently in both small and large scale. So scalability definitely is the basic concern. So build an architecture that will scale, but start prototyping with a small number of devices. It's hard to predict what data provides value, which imparts, which sensors and devices are necessary until you build something. So initially prototyping or doing it at a smaller scale is important, experimenting, learning, and then refining your solution before going to the scalability. But still, scalability is an important issue. Then another important issue when you go to IoT application development is called interoperability. There are numerous IoT platforms available in the market, and each of these platforms promote its own IoT infrastructure. The proprietary protocols or interfaces, incompatible standard. So what is going to happen because of that? So this is going to create a system of silos, or you have to be dependent on a particular, let's say, if you say that for my infrastructure, I can only use the microcontroller by ARM, or I will not use the micro sensor by a particular manufacturer. So if this is done, definitely, if that manufacturer stops the manufacturing of that sensor or a particular processor, the latest version of the processor comes into picture, your system is going to fail. You will not be able to replace a particular version of a processor with another version. So while designing the system, I have to take care of the interoperability also. I must be able, so let's say partially in my, when I'm going to get data, let's say for one application, this data can come from different sensors. This data may come through different communication technologies. This data may come from different processors. So interoperability is very important. Necessity for these different solutions to seamlessly work together. They must work seamlessly together as if they are part of one system. So ability of different information technology systems, software applications to communicate, exchange data and use information that has been exchanged. So interoperability is one of the important parameters. So if you lack in interoperability, means that the service providers are bound to the IoT device or software offered by a single provider. And in order to avoid this, industry attempts to address the IoT interoperability, and that brings into the standardization concept. So standardization, so there are n number of ways where interoperability is required, the low end or a high end capability of the devices or the networks, the semantics, the platforms. And in order to bring it, there are many governing bodies. So there are many governing bodies like ISO, W3C or ITU or IEEE, ZigBee. So these technologies or these governing bodies, they are helping us in interoperability so that one device can be used by different ways. Or so the design requirements, if you come to IoT design requirements, the IoT network has impact on many of the IoT system design. So scaling is decided by the IoT network. The heterogeneous endpoints, they decide have the impact on it. The capex and the opex requirement, what is the capital investment or the operational investment, how many gateways are required, criticality of the service, inclusiveness, and the geography where you are going to do it. We'll go in details of this in a while again. So now security and privacy is again a very important point when you are coming to IoT, or as everything is now getting connected to internet, definitely all the attacks which are possible on internet are possible on these devices also at every layer. So privacy and security issues are definitely very important, but can become a separate topic for. So let me just switch the so I'll just introduce to the basic IoT architecture, and then we may take a break afterwards. So basic IoT architecture. So there are n number of ways by which IoT architectures are defined, or we may also go through few of them. But the basic architecture, basic requirement for any of the IoT development is, first is the perception layer, which is where your things are getting connected to, or you are gathering some information about the things. So sensors are the main part of the perception layer. Then network layer, because these sensors have to communicate the information. The next important parameter is the network layer. And then you have to create a user interface. You have to store the information. So you need clouds or servers, or you need some applications to access the data. So these are three major blocks or three major components of any of the IoT architecture. Starting with, we may go in any of the way. From user point of view, the application layer comes first. From the application layer, you can go to the network layer. From the network layer, you can go to the perception layer, or the other way around is also possible. So perception layer has got sensors, microcontrollers, or the signal conditioning system, and the data is converted into a structured format. From there, the data is to be communicated. So you need the routers, gateways, and then the application layer. So basic IoT architecture. So we'll first go to the perception layer. Perception layer where you have sensors, a number of sensors. Why only sensors? There are actuators, because sensing as well as control are both the parts of the perception layer. You want to sense something and you want to control something. So sensing or perception layer, then the network layer, and then the application layer. So as we have just seen the things in Internet of Things, or there are many things. So how to connect the physical object to IoT? So either with the help of sensors or actuators, or using the identifiers like the RFID tags, the QR codes. There are n number of sensors. There are n number of physical parameters to be sensed, and depending on the physical parameters to be sensed, there are n number of sensors. Even with a particular parameter, let's say if I say I want to measure temperature, there are again n number of temperature sensors, depending on the accuracy with which you want to sense the temperature, depending on the range in which you want to sense the temperature, or maybe depending on manufacturer, depending on the form factor of the particular sensor. There are n number of ways in which sensors are available. So temperature or motion sensor, humidity sensors. Same example, if you just see, you have a smartwatch. A smartwatch, you can get it for 1,000 rupees. A smartwatch you can get for 10,000 rupees, or a smartwatch you can get even for 50,000 rupees. So in all these smartwatches, there are sensors which are measuring your, let's say, your body temperature, your number of steps counted. What differs is the accuracy with which the parameters are measured, and the accuracy with which the decisions are taken, the accuracy with which the data is processed. So reliability of the sensors, or the way in which the sensor is manufactured, or whether it is precise sensor, it is accurate sensor. These are the parameters which are definitely going to decide the life of your particular device, the accuracy with which your device is going to work. So as you can see here, there are a number of ways, a number of parameters can be measured. So few example sensors I have shown here is LM35 is one of the IC temperature sensor. It is an integrated circuit having only 3 pins, and this can help you measure the temperature, even the body temperature, called LM35. Then a sensor which is called as ultrasound sensor. This sensor helps you in many of the application, initially designed for finding the obstacles, or it has a transmitter, it has a receiver. The transmitter sends the signal, and if something comes in the range of the signal, the reflection coming from it is measured by the receiver. And depending on the time of flight or the time the signal takes to go to the object and come back, you can measure the distance. You can use the same thing for measurement of velocity further, because these things are related to each other. So a simple sensor which will help you to find out the distance of the object. Now definitely everyone knows about the number of sensors which are there in smartphone, and day by day while choosing the smartphone, we are taking care of the sensors which are there in our phone. So there are sensors which are accelerometer, temperature sensor, color sensor, humidity sensor, proximity sensors. N number of sensors are getting embedded into a phone, getting embedded into number of devices also. So N number of sensors helping us measure a number of parameters, communicate a number of parameters. Similar is the case with a smartwatch. A simple smartwatch can help you measure n number of parameters. Again, one of the field where n number of IoT application possibilities or opportunities are coming. We have n number of sensors in every part of automotive. So it was said that earlier a car used to be 70% of mechanical and 30% of electronics. Now we can easily say that it is 30% of mechanical and 70% of it is the electronic system. In every part of the car, automotive, any of the automotive, there is electronics. There are sensors, there are actuators, there are processors even to process the information. There are LCD screens. So everything is connected. And not only this, now you have the connectivity as one of the important issue. We are going towards automotive cars, or we are designing the sensors with the lidar like sensors, or lidar cameras are used, which helps you even making a automotive vehicle or guided vehicle, or we can say driverless car. So in short, while designing a simple IoT system, you need all these parameters. We'll come to this again afterwards. So first step is sensors. Now these sensors are to be connected somewhere. These sensors, if at all they are intelligent also, we need to process the data which is acquired by these sensors. So we need to condition the data acquired by this sensor. We need to bring the data in a format which will be understood by the remaining systems. So there are many devices which we can say few of these devices, these were called as open source hardware platform. These were open source hardware platform. Now what we were knowing about the open source software platforms, but first with the concept of Arduino, the open source hardware platform came into picture. And with these open source hardware platform, the applied Internet of Things, or bringing some small prototyping ideas of the Internet of Things application, became realizable to even nowadays. Even a school child can use Arduino because it is open source hardware. It's very easy to understand. the development environment is provided with the Arduino. You need not be an electronic engineer in order to connect sensors to actuators or in order to develop a prototype IoT based system. So Arduino is one of the basic pioneer in making the IoT development possible and called as open source hardware, where the basic protocols, without even knowing about these basic protocols, a person can realize a system. Then there are, as I discussed with Intel, there was Galileo, which used Arduino as well as additional facility. With the improvement in the communication technology, with the improvement in SoCs, the devices, small devices like Node MCU came into picture, which the parameters which were lagging in Arduino are now there in Node MCU. Same I/O capabilities. You can easily connect an input device sensor. You can easily connect output device or actuators, as well as you can very easily connect it to internet. So this simple Node MCU device, it has got Wi-Fi connectivity. It has got Bluetooth low energy connectivity, and depending on your application, you can choose the connectivity, you can connect it. So similar, many manufacturers have brought many hardware platforms for prototyping of the IoT system, MSP 430 or TIVA, then BeagleBone Black, or the Raspberry Pi is again one of the leader in this particular domain of edge devices, where the basic purpose is to gather the data collected by the sensors, process this data before sending it to cloud, or process this data. There are some application where you need not go even to the cloud. So process this data and then give the inference. So Raspberry Pi is slightly different as compared to other devices. This Raspberry Pi, we can call this as single board computer. So this has got its OS also. It has got its operating system. You can connect the keyboard, mouse, and a screen so that it will become a computer. And you can program it as per your requirement. You can customize it as per your requirement or as per. So this shows a Raspberry Pi, which has wherein you can add your operating system and make this simple device, a credit card size device, a single board computer. And you can realize your application because it has got many of the general purpose input outputs. It's called GPIO is one of the term which you can you either have heard or you will come across if you want to go for IoT application. So general purpose input outputs, many pins are there wherein you can connect the sensors or actuators and use this device for development of IoT application. So Girish sir or Sonali, can we break here for some time or I can continue for some more time?
Madam, we'll take a small break.
Okay. And before the break, we will go ahead with the Q&A and some comments that we have received and some examples that we have received from the audience. I'll share that first. So,
Yes.
so Dharamveer is saying that RFID is also used to capture time in case of marathons. Praveen is saying it's a very interesting coverage. Mohammed says that sensors are also used in football matches for checking the offside goals.
Yes.
Amit says it's a great insight into the IoT edge devices. So these are some of the feedback and inputs from our participants that I shared. And now we will get to the Q&A. So Harish is asking, is mobile hotspot and IoT?
Sonali, your voice is a bit lower.
Okay.
So can you?
Okay. So Harish is asking if mobile hotspot is IoT.
Okay, mobile hotspot is one of the communication technology which will help you to connect to IoT devices. So mobile hotspot becomes one of the communication technology. We'll definitely come to that in the second slide, wherein I need to connect my device. When I want to connect my device to internet, sometimes it is not possible for me to go directly to the cloud. So initially I need a short range communication technology. I can, through my mobile hotspot, I can connect my physical device to the internet or to the cloud. So your hotspot will become one of the edge device or one of the router using which my data will go to the cloud.
Okay, thank you, Vinaya. The next question is from Krishnan, and he is saying RFID is not necessarily connected to internet, but does it still come in IoT?
Yes. So RFID, as I said, everything need not be connected to internet. Somewhere the application. So let's come to when you come to RFID, it is radio frequency identification. So RFID, we know that we are using RFID, as I had already given the example of a FASTag. Let me come to that slide. So when I say I'm using FASTag, my car has RFID tag. This tag, let me tell you that this tag is a passive tag. This tag is a passive tag. This tag has some information stored in it. That some information can be the number of your car, the number of the owner of the car, maybe some more details regarding the purchase of the car or something else. And from this, it has got a processor also, some memory also, and an antenna also. Now, when this RFID tags come in contact with a device called as RFID reader, this RFID reader, which is there on the toll booth, when the tag comes in contact with the RFID reader, this gets energy and it gets connected to the RFID reader. It transfers the data from the tag to the RFID reader. And further, this RFID reader is connected to internet because your bank account is also connected to your tag. You need, in a smart or we can say short amount of time or very smartly, this RFID system, it is even called as EPC or electronic product code, EPCIC. This deducts the amount from your bank or the money which you have already deposited in your account, and the system completes the transaction. So unless this RFID reader is connected to internet, this will not happen. So RFID tag may be not directly connected to internet. So everything need not be directly connected to internet, but somewhere it has got a part in.
Right.
So I
Yeah.
hope that answers the question.
Right, right. You had touched upon this, Vinaya, about active and passive, and I think the passive part explains this question.
Hello? Yes.
Okay. So the next question, Vinaya, is from Naushad sir. He is asking, what about security and safety issues, as hackers may attack electric grid or medical devices?
Yeah. So this is definitely, as I said, a particular area which even need a separate webinar. So there are a number of ways by which your system can be hacked. At every network layer or every layer of IoT, there can be attack. There can be different attack at different layers. So security is one of the concerns. So while coming to the protocols, we'll consider to some extent how security is taken care, or what are the applications where security is more important. Because the applications where your bank account is definitely connected, you need to be very much security. Or if the applications where your personal data is at stake, definitely privacy issues are also there. So security and privacy in itself is a separate, we can say, branch in IoT. So as IoT is, again, I repeat, is not a, or it is not a new technology. It is a concept and it is integrating many of the technology. And security privacy is one of that. To some extent, in the next part, we may touch it. But definitely, yes, security and privacy are the important issue.
Okay. Thanks, Vinaya. The next question is, what is the mechanism to ensure that data collected by IoT devices is only used for the purpose for which it is collected and not misused? This is from
Yes,
Dharamveer Gupta.
again, it is the security and the privacy issue, or the branch which data science, how data science or big data is connected to internet or IoT applications.
Right. Okay.
So encryption of the data can be done, or depending on the security requirement of your data, you can use the encryption technologies, or you can use the technology or protocol so that your data is secured.
Okay, thank you. Next question is from Anil. He is asking, existing PLCs, can they be used as edge aggregators?
Existing PLCs.
Right.
Yeah, to some extent in industrial Internet of Things, the existing PLCs, by adding some communication modules to them, can definitely be used for IoT or industrial Internet of Things based applications. There are protocols are comparatively different when it comes to the industrial IoT and the ubiquitous or the basic IoT.
Okay, so that's about the questions so far we received, Vinaya. And
Okay.
thank you for the interesting session so far. We learned a lot about IoT, and IoT can be used to connect anything, anytime, any place. It is used to see, hear, think, perform different jobs. So with this, we can take a short break. Girish
Yes.
sir, would you announce about the break?
Yeah. I would like to invite Ms. Priya Madam, VP Outreach, to share PMI chapter exchange details. Over to
Yes,
Priya
yes. Thank
Madam.
you, Girish. Yeah. So I would need the sharing rights if that is possible. Okay, thank you. And here I am. I'm sharing my screen. Let me know if you're able to see. Okay. So I'm here to, I am Priya Patra, your Vice President Outreach. And thank you everyone for supporting our outreach initiatives. And one of our flagship initiative is the Chapter Exchange Initiative, where we go ahead and reach out to different chapters across the globe. And we have built a virtual global community of chapter leaders. And we kind of do co-create monthly events, and this announcement is to invite you to join that monthly event, and you will get 2 PDUs for it, for joining that event, 1.5 PDUs, sorry. And to this month we are talking about project management for innovation, research and development, and fuzzy projects. Which is kind of interesting, because when we think about innovation, we think about research and development, we really don't know what is the outcome. And, how do we stir ourselves, or as project managers, manage these projects to get the desired outcome. We also do have Ricardo Vargas, who is a influencer and thought leader in project management, to as our guest speaker, as our keynote speaker for this event. And apart from that, we have panelists from all across the globe, from Africa, North America, Europe, Latin America, and Middle East, joining this event to sharing their global views on this very topic. So you will see that we have diverse panelists on this event. Each and every event will have a diverse panelist. This time we don't have representation from Asia, because we have to restrict the number of panels to 5. We cannot go beyond that, otherwise it becomes chaotic. But next month we have representation from Asia. So it is rotated amongst the chapters who are part of this program. So we are just this announcement is to, as I said, to invite you to join this event. I'm going to put on the registration link on the chat window. Please do register. join, and you will not be disappointed. That is for sure. Month on month, we have more than like 600, 700 attendees joining from 65 plus all countries in this event. It is a great opportunity, first of all, to earn PDOs, learn something new, which is even a bigger opportunity, and network with people from all across the globe. So please do join us, and and come and your overwhelming response is the key to success for this event and this initiative. And that is all from my side, Girish. I will stop sharing and I will put the link for registration on the chat window so people can register and join.
Madam, thank you. Now we will take a small break of 10 minutes, so 5 minutes. So we will be back at around 11:30 a.m. Thank you. Welcome all. After a small break, feedback link will be provided in the chat box. Request all participants to provide your feedback so that we can incorporate changes in our coming sessions. PDF details will be provided to all participants through mail ID as per attendance. Dr. Vinayji, over to you.
Yes, thank you, Girish sir. Hello, am I audible?
Yes, madam, you are audible.
Yes. So let's begin with the next important layer in the IoT architecture, which is the communication layer. What drives this communication layer, or what are important parameters in this communication layer? So as you can see, the IoT varies in communication. We have seen there are n number of applications of IoT. And as there are n number of applications, definitely there are n number of sensors, there are n number of actuators, and depending on the application, there is need of the communication system. There are some communication or requirements which are called mission critical requirement. So mission critical, or the requirement, let's say if suppose we are doing some thing related to medical diagnostics. Yes, power system is also one of the mission critical requirement, wherein you need to measure the power, or you need to be always connected to the power. You need to measure the power every 10 times in a second. There is a requirement where you have pacemaker or some body related data or body area network, and you need to measure the parameters. You need to measure your heartbeat. So you need to measure it at a very high rate. Then there are applications where my application is delay tolerant, or I can say that in a agriculture farm, if I get my data after every 1 hour is also sufficient. If it is application like traffic monitoring system, so depending on the time in which I have to switch on or off the traffic lights, I have to decide my communication requirement. I have to operate my actuators. I have to switch on the lights from red to yellow and to. So depending on the application, depending on the way in which I am connecting my sensor or I'm operating my actuator, I have need of my communication system. So communication is changing with respect to every application. But finally, if I want to design a good communication system to make my IoT application successful, I need to consider that it is taking or it is a low cost solution, it is a low power solution, it is definitely allows me to use the battery for longer duration. So there are algorithms by which I can make the battery power long for more time. There are higher number of connections, different bit rates. In some application, if you consider I have a small data to be transferred, let's say only a temperature data, few bits are to be transferred or few byte to be transferred. There are applications where if I have a camera for surveillance, I may have to send a data which is in kilobytes, with data which is in MBs. So depending on my application, there are different bit rates. So my communication need will depend definitely upon what is the data rate I desire. Then whether I have to send the data to a longer range or I have to send the data to a smaller range. Then low processing capacity or low storage capacity, small size of the devices, simple network architecture and protocol. So all these are the requirements I need to consider while designing my communication system. While selecting out of the many options which I have to select one option, and that option should optimize all these parameters. In addition to that, depending on where you are trying to develop the application, whether my application is in the rural or remote area, where my communication behavior of my communication system is different. My communication signal will be behaving in a different manner, because in this rural area there are trees or let's say hilly area, and there can be absorption of my communication signal, or I may not reach, or I do not have a nearby station, or problems are different. In an urban or a dense urban area, again the problems are different. Sometimes there is attenuation of the signal or reflection of the signal because of the dense populated buildings. So n number of different challenges are there when we are using the communication system. Then there are unlicensed and a licensed band. Unlicensed band, which are free for use. Generally 2.4 gigahertz is one of the band which is made free. In this particular band, if you are designing any application, you need not take permission or you need not pay for the bandwidth. And then there are licensed band, like for 4G or 5G, when a particular service provider wants to get the license, he has to pay for it. And because of that, we have to pay for the application, or we have to pay for the data, we have to pay for the use of the data. So the spectrum in which you are making your design. But definitely, if you are using an unlicensed spectrum, in this spectrum, there are going to be many different users, those who are again willing to use the free band. So there can be possibility of interference. So you need to take into account that also. So these are first two things, like the coverage zones where you are designing your application for which you want to design the communication system. Then there is spectrum use for which you are designing the application. Then there are a number of ways in which the network can be achieved. It is local area network, personal area network, or wide area network. If your application demands you need to use low power wide area network, the frequency range which you will be using, whether you want to use the satellite or then the spectrum which is called wide spectrum or TV wide spaces. So depending on the type of network, again, you have to make a compromise, or you have to make an optimal solution of using one out of that. Then commercial services, the public or the private services. So IoT service and a network provider or IoT operators in the public space. And then there are networks owned by the actual IoT service or application providers. They use private network for their own development. So again, this is one point which you need to consider while considering the IoT application. Now there are, as we have seen, there are n number of requirements. There are n number of protocols or n number of technologies which are coming into picture for satisfying the requirement of IoT application. Earlier, we were knowing only about the 3G or 4G technology. Let's say we were knowing about the Wi-Fi or Bluetooth technology. To some extent, we now know about RFID or near field communication. So proximity networks or RFID or NFC, tap and go, when you are using your card, using NFC card for paying your purchases, you are using a NFC or proximity network, which has contact or proximity range up to 10 meters. So in 10 meters, they can work in 10 meters. Like, as I said, the tag or the RFID card need to come in the range of reader, unless it is very close to the readers, unless it is in the range of the reader, the information on the tag will not be transferred to the reader. But this reader has to be always connected to internet. Unless that is done, your money is not deducted. Or your system is not complete. So tag and the reader, the proximity network. Then up to 10 to 100 meters, we can use wireless personal area networks. Under this wireless personal area network, the well-known technologies of Bluetooth or we can say wireless HART or Zigbee, you must have heard about, or Z-Wave, which is generally used for home automation kind of applications. These are there. Then up to 1 kilometer or up to 1000 meters or short range, we have the technologies like super Wi-Fi or Wi-Fi Hello. Then wireless up to 10 kilometers, we can use few other technologies. And then if beyond that, we may have to use the cellular network. But again, once again, to remember, for cellular network, we have to be cellular networks are designed for human-to-human communication. So the way in which we are using it for IoT application, we have to decide it in advance. Now with 5G, again, more and more avenues are opening for IoT applications. New frequency bands are coming into picture, higher speed of operation, higher data rates. So depending on requirement of 5G, but still we have few more days to apply 5G to IoT. So as I said, there are fixed or short ranges, Bluetooth, then Zigbee or Wi-Fi, operating in the range of 2.4 gigahertz. Bluetooth has a range up to 50 meters. We all experience it. Bandwidth of 2 megahertz. Zigbee again operates in the same frequency band. Range is less than 1 kilometer. Maximum data rate possible is 250 kilobits per second. So if you have small data packets to be transferred, then you can use Zigbee. Wi-Fi definitely has got advantage of the higher data rate. I can get 54 megabits of bits per second, and the range is also comparatively more as compared to Bluetooth. Again, the license or the free band of 2.4 gigahertz and highest channel bandwidth of 22 megahertz. Then for long range communication, specially designed protocols are LoRa, which is long range communication, can go up to few kilometers. We have tested it that even in the dense environment of Kothur area of Pune, we were able to test the LoRa modules up to 2 to 3 kilometers. The signal transmission can be done. And one of the basic reason behind why you have higher range here is the frequency band use. LoRa uses the sub 1 gigahertz or 800 to 900 megahertz range, and that makes possible the use of higher range. But again, data rates are up to 50 kilobits per second or higher data rates are not possible. Then with Sigfox again, so there is a relationship between the frequency range and the distance it covers. So lower frequency ranges covers a longer distance. So with again sub 1 gigahertz, you have ranges more than 20 kilometers and you can get a maximum data rate of 250 kilobits per second. So higher data rates as compared to LoRa, higher bandwidth, channel bandwidth as compared to LoRa. So again, depending on your application requirement, you can choose one out of that. So a comparative graph showing the relative power use of this technology. So BLE or Zigbee, Bluetooth low energy definitely takes less power as compared to your Wi-Fi or 4G or WiMAX network. So Zigbee also comparatively similar to BLE. Then relative range, if you consider, the BLE has the smallest range as compared to that Wi-Fi or Zigbee has a higher range. And for maximum coverage, you can go to 4G or LTE. As far as data rates are considered, you can consider Wi-Fi if you want to send the high data rates, or if you want to have a security system of cameras, so many cameras connected to each other, you can think of using Wi-Fi in place of BLE or any other network. So some of the short range IoT solution, to some extent we have discussed them, but in short, once again, we'll see about the RFID technology. So used for identification of objects, there are many ways in which RFID tags are designed, or the frequency ranges in which the tags are available. So we have the tags available in few hundred kilohertz, 13.56 megahertz, then even at 2.4 gigahertz. Generally, these tags in the lower frequency ranges are called inductive. They are passive tags and they get energy for the operation when they come in contact with the reader. So whenever they come in contact with the reader, they are energized or they get power. So they do not have their own power supply. So they get energized. It is called inductive coupling. They are, and once they become they are powered, they convert or transfer the data to the reader. Further, there is EPC network or enterprise system through which the data is processed and the things are done. So like when you use it in retail industry, there are n number of objects which are tagged with RFID tag, or even for the fast tag, there are n number of cars having unique identities. So every car has unique identifier. So maybe a 32-bit identifier which is unique to that particular car. And how to identify them, how to categorize them, how to partition the resource, all these things are done by the enterprise system or called as EPC network. Then Bluetooth. So as again said, Bluetooth is class 1, 2 or 3. So if you want to increase the range, you need to increase the power which you are transmitting. So 100 milliwatts of power is transmitted if I want 100 meter range. And for 1 meter range, I am transmitting 1 milliwatt of power. So 1 milliwatt of power at a frequency of 2.4 gigahertz. So Bluetooth, as again, it is in the ISM band or it is in the free band, wherein without any permission, you can develop your own application. With Bluetooth 5, we are expecting more range, more speed, and the message capability. At present, Bluetooth 4 is used in almost all the phones. Then Zigbee, as I said, technology which is developed for home automation kind of application. So Zigbee, further, it is Z-Wave is one of the technology which is used for home automation kind of application, where you have a coordinator, a router, and an end device. So a coordinator acts as a root or bridge of the network. So this simple home automation application can be seen here. You have a Zigbee network and the coordinator, Zigbee coordinator shown red here. It connects the Zigbee nodes or routers and then the Zigbee end devices. So the end device, let's say one of your fan, is connected through this Zigbee router to the coordinator, and through this coordinator it is connected maybe through a wired network or a wireless connection to the system. So it is a kind of mesh network or a network of routers, coordinators, and the end devices. The topology can be different in which they are connected to each other. That will again depend on what are the places or how is the structure of your home and how many devices you want to connect. But finally, it is a network which is created for home automation kind of device. Then Z-Wave, as I said, again, it is used in home automation, a modified version of Zigbee. Then a latest protocol in this particular category is called Wi-Fi Hello or Wi-Fi AH, which is a new low power long range version of Wi-Fi that is particularly designed for IoT applications. And once again, to increase the range, this Wi-Fi Hello, instead of 2.4 gigahertz, it is at a 900 megahertz band or a lower frequency range. So lower the frequency, higher is the range. So the protocol's low power consumption competes with Bluetooth. So Wi-Fi customized for the applications of IoT is the Wi-Fi Hello or IEEE 802.11ah, and you can get a range up to 1 kilometer with Wi-Fi Hello. Still under let's say experimentation or So Wi-Fi Hello, as it is said, 900 megahertz and specially designed for higher data rates and wider coverage area, even low power consumption. Now, few of the long-range IoT solutions. So long-range IoT solutions, which are either third generation point-to-point communication standards or non-3GPP. So under this non-3GPP, we have LoRa as one of the, in the LoRa, L stands for long range only. So long range communication, we can get communication in kilometers range. Again, a system designed at a lower frequency range. Then Sigfox, weightless, these are few of the new technologies which are coming in recent years for, especially for the IoT applications. And then narrowband IoT or 5G applications are also coming up in 3 different bands at lower frequency range, then at again higher frequency range and even a higher range of gigahertz. So LoRa Alliance, which as I said, it has recently come into picture and still it is experimented in for many of the application, but has advantage of a longer range. Then Wi-Fi also has many different ranges, as we have just discussed. Wi-Fi Hello is a 900 megahertz range, 8 megabits per second, and up to 100 meters you can go with it. While another spectrum available for Wi-Fi application is now 5 gigahertz, where you can get a higher throughput or 54 megabits per second can be transferred. And the range is up to 10 meters, while the usual 2.4 gigahertz range, also B and G are 2 options depending on the throughput requirement. So if I want to transmit 11 megabits per second or 54 megabits per second, I can select between these two. So wireless alternative to the wired technologies can be used in any of these applications shown here. So depending on if I have multimedia application wherein my requirement is higher throughput, I can select an application which will give me higher data rate. If my application is longer range, I can select the depending on the highest range or depending on if I have a highest range requirement, I can go for 900 mega. So I can select a technology depending on my application area. Then LoRa is, we have seen already few of the applications. So range up to 5 and 15 kilometers, strong indoor penetration. It is robust, resistance to Doppler effect or multipath effect. So in the environment or where tall buildings are there, the Doppler effect or reflections coming out of these buildings will not help, will not cause any effect on weakening of the signal. So will still penetrate through buildings and will reach the destination or receiver. So we won't go in much details of LoRa architecture. Those who want to connect will take it afterwards. So LoRa device classes, there are many classes depending on the example application. You can go for a particular class of application wherein either class A has only listens only after the end device transmission, or B has beacons also. The module listens at a particular frequency range, or C module always listens. Then is Sigfox, one of the newest again technology which is coming in picture for IoT application. So Sigfox again has extended range up to 50 kilometers, has roaming capability, 140 messages per day per device, but again for a low throughput application. So when the data to be transmitted is smaller. So in the similar manner, you have the structure for the Sigfox also, the end devices, the gateway connected to network, to cloud, and then through the Sigfox gateway, it is connected to end device. So there are n number of IoT cloud platforms also available, which allows you to go for easy deployment of your application. So starting from Google IoT platform to the Amazon AWS IoT Core, which is we can say #1 these days, or Microsoft Azure IoT Hub, which is also helping in many applications. So now as a general architecture, you have the protocols at the physical layer or perception layer, then you have protocols at the network layer, then you have protocols at the application layer. So at the application layer, which is generally responsible for providing the application specific services to the user. So you, on your phone also today, you have many of the applications which are already, you are using Ola or Uber for booking a car, or you have many of the applications which are helping you to connect to the like Amazon or Flipkart, or you have applications like Swiggy to order something, or many of such applications are already there, which is helping you, or which you can say you are using some of the IoT applications. So at every layer you have the application. Now if you consider the IoT stack with the web stack, where are the differences? So you can nearly see that at the network or link layer, at the internet layer, at the transport layer, application layer, the protocols are different. Basically, at the application layer, many good protocols are coming into picture to replace HTTP, which is the basic protocol in web development or web stack. So as I said, there are many architectures depending on the requirement of the user. So as this perception layer, network layer, and application layer is the basic architecture, this further is divided into the application layer can be reduced, and then middleware layer or the coordination layer and the backbone network layer is added, and the perception layer is divided into access layer and the edge layer. Or there is a architecture which is called as service oriented architecture, where the picture or the architecture changes as we have the perception layer and application layer, and in between there is service composition, service management, or the object abstraction layer which is done. So this is a well accepted architecture which is called as service oriented architecture. And then there is a business layer added to the architecture and becomes a 5-layer architecture. So object abstraction layer, service management layer, application layer, and then the business layer. But basically, these are the basic 3-layer: perception, network, and application layer, which are further divided by different organizations as per the requirement. So in short, now I'll go to the last part of it, which is IoT protocols. So few of the challenges and then few of the protocols. So few of the IoT challenges are architecture, communication, security, privacy, interoperability, integration, device type and sensor technology, deployment models. So the communication in case of IoT can be device to device, it can be device to application, it can be device to gateway, and it can directly be even device to cloud. So depending on how you are connecting the things, there is requirement of protocols. So if my application requires that I use a local gateway and then connect the data to the server, if my application requires that I can connect my device directly to the cloud and the can be accessed by the others. So depending on my application requirement, there are So now this is called a communication-centric IoT reference model or architecture. So at physical layers, I have few of the protocols. At data link layer, now the Z-Wave, NFC, which we have seen, Sigfox, LoRaWAN, Wetless, these are at the data link layer. At network layer, we use IPv6 or 6LoWPAN. At transport layer, I can use TCP if security is my concern. I can use UDP if security is not my main concern. Then at application layer, they generally use protocols are MQTT or constrained application protocol. So choosing a protocol definitely decides the fate of your application becoming successful or it is not becoming successful. And so it is a very important step while choosing a particular protocol. So while choosing a protocol, IoT device, typically you have to consider that limited computational power and processing power. You need to choose a lightweight protocol which will not burden your system, in turn will save your power. It is a reliable protocol, it is a scalable protocol, interoperable and secure also. So, and at the same time, you have to remember that not all protocols support all identified communication types. So while choosing the protocol, you have to be very careful. So few of the IoT system requires a high velocity, require lightweight application. For example, a small battery supported IoT temperature device, if it is programmed to send the temperature data after every 10 seconds, then if you are using HTTP protocol, it is definitely drain its battery very quickly. So HTTP will not help me in that case. So instead of HTTP, I have to use a protocol which is lightweight, which is taking low battery. So in this way, you can compare the protocols depending on the data rate, depending on the layer at which it is there. So Z-Wave or Wetless will become a protocol, important protocol at physical or the data link layer. Depending on application, I can decide my protocol. So industry automation or smart metering, smart building. Depending on my application, I have a range to be addressed. And for that particular range, I have a technology to support me. Depending on my throughput requirement or the data rate requirement, range requirement, again, I can compare all these technologies which are available at my hand. So at network and transport layer also, there are technologies. We have just discussed about Wetless. So Wetless also is available in 2-3 different categories. So Wetless N or W or P. So P is generally used for ultra narrow band or sensor based application, while other two are used for some other spectrums. So IPv6, which is one of the protocol which is used at network layer and it is coexist with IPv4. I had few questions, so if you permit, can we take the questions or shall I go ahead? Okay, so I guess we are running short of time. So I'll just address the IPv4 challenges and what IPv6 offers to you. So IPv6 offers or helps you in, okay, I'm unable to hear once again. Okay. So IPv6 has 128-bit address line, and this now helps me in addressing n number of devices. It has got plug-in play mechanism, so it helps me in addressing security challenges, addressing my number of scalability, and it is a better optimizer. Now IPv6 for low power application is called 6LoWPAN, and it helps you in again a low power wireless solution. So at transport layer also, you all must be aware of TCP and UDP. So out of these two, generally, depending on your application requirement, you can go for either TCP or you can go for the UDP protocol. So these are again few good protocols used at application layer or in the acceptability of these protocols. So most of these cloud platforms, they use MQTT or constrained application protocol. So HTTP, again, is a request response protocol. Then constrained application protocol depends on HTTP, while if just compare for the internet or Internet of Things based applications, COAP replaces HTTP, TCP is replaced by UDP if security is not your concern, IP is replaced by 6LoWPAN or IPv6, and MAC and physical layer may remain as it is. So constrained application protocol, as again similar to HTTP, they use GET, POST, PUT or DELETE and are of many types. Those interested can connect to me if you want to know more about it. So MQTT is considered today's publish subscribe kind of protocol, where it is a M2N kind of protocol wherein those who have the data can publish the data to the broker. The way in which you want to, if suppose I want to book a house or rent a house, I approach a broker, and if I want to rent my house, I also will approach the broker. So the tenant and the owner, they are connected through the broker. In the similar manner, those who are having the data, they publish the data to the broker, and those who are in need of the data, they subscribe for the data to the broker. So as the broker connects the publisher with the subscriber. So M2N kind of connection, and it is getting many attention in the IoT world today, wherein using publish subscribe kind of network, I can connect or realize many of the applications. So for home automation also, this is going to be one of the, so there you have connection or. So I guess as the time is up, so we'll just go to the comparison. So these are with the today, the protocol which is having highest importance is MQTT as compared to the other protocols. The IoT technology trends to watch in 22. Nowadays, IoT is now getting converted into IoT or AIoT it is called, the intelligent IoT it is called. So as a lot of data is created out of IoT applications, the data can be analyzed in different ways. Data can be used to train the AI-based systems, models, and the system can even be made intelligent. So AI is becoming a part of IoT, doing the operations as the edge devices are becoming intelligent or powerful. Everything is, instead of transferring to cloud, that analysis is done in the at the edge itself. 5G is becoming IoT ready. So all these are the things which are the trends to watch in 22 or in the future of IoT applications. So I think we'll take up the questions now. So I'll stop my presentation here, and if at all there are a few questions, I'll be happy to answer it.
Sure, we'll go ahead with the questions. Thank you for the session so far, Vinaya, for explaining the IoT network architecture, the protocols. So are you able to hear me well, Vinaya?
Again, same issue. I'm unable to hear properly.
Okay.
Yes.
Okay, so we'll go ahead with this.
So we can try it once again, Sonali.
Okay. Okay. Yeah.
For the earlier one? I do not know what is problem with audio today, but
yeah, I think this is better, right?
Okay, now what I'll do is, okay, that also I cannot do. It's better now.
Okay, so Jacob sir is asking that if an IoT is on 5G and another one is on 4G. So what is the outcome? What can be expected?
Now, we know the difference between 4G and 5G. With 5G, we'll be able to get higher data rates, more bandwidth will be available to us. So the applications which are, let's say, not delay tolerant or mission critical applications, for that, getting the outcome as early as possible will be possible with 5G. Definitely, we need some changes because 5G infrastructure requires few more. 5G is getting ready for IoT, I can say.
Okay, thank you, Vinaya. The next question is from Amjad. He is asking what are the health consequences of these high frequency devices?
Yeah, it is. We can say to some extent this is true that at very high frequency, if higher power is transmitted, then it may affect a human body. Or if you know, I just want to give the example, like 2.4 is the frequency we use for Wi-Fi or Bluetooth. Same 2.45 gigahertz is the frequency which is used in your microwave oven. But the only difference is in microwave oven, the power is much higher. And for the power, there is always a limit on how much power you can transmit using your radio frequency devices or your transmitters. So this frequency this power which is transmitted by these devices, there is always a upper threshold on it. And so it is tested that it is not affecting to human body.
Okay.
But yes, at higher frequency, the power has to be minimum.
Okay. There is a related question from Trupti. She's saying, is there any proactive way to measure overusage and avoid health hazards?
Can you repeat it, please?
Yeah. Is there any proactive way to measure overusage and avoid hazard to human health?
Yeah, that is definitely possible. So as I said, there is always upper threshold on the maximum power which you can transmit. So if the maximum power transmitted, it is getting measured also. So there is always a watch by the governing bodies on maximum power which you can transmit. So the threat to environment is taking into consideration. It is already taken into consideration while designing the IoT communication system.
Okay. Dharamveer is asking, how do you compare 5Gi, which is the standard used in India, with other countries? How do you compare 5Gi, the standard used in India, with the 5G technology of other countries?
Okay. So I'm not an expert to talk on 5G technologies or 5G in India. But at present in 5G also, we are not going to the higher frequency band. We are still working in the lower or 5 to 6 gigahertz band as far as 5G is considered. So 5G may operate in the very high frequency like 28 gigahertz band also. But at present in India, we are experimenting on the band or 5 gigahertz band, which is a middle band. Even there is one lower frequency range also for 5G. And definitely we are working only at the 5 gigahertz range. We are not experimenting at very high frequency, which is around 28 gigahertz.
Okay. Do you have any suggestion on the best IoT device manufacturers in India or around the world? Do you have any suggestion or recommendation on who are the best? That's from Biswajit.
I won't say there are many good manufacturers for IoT devices. ARM is one of them. Then there are a number, depending again on your requirement. If your requirement is AI-based IoT, then NVIDIA may support you. Or if your requirement STM, if it is low power requirement, STM is one of the manufacturers. So like I'm talking about the controller chips or the platforms which may use for it. So Arduino is one of them, Raspberry or ARM based devices or microchip. So many options are there, and finally it will depend on your requirement.
Okay. So that's for the questions for the session, Vinaya, but we have very rave comments from Preeti, who has joined us from London, and Savita and Sheila and Shashikant and Prashant, Mohammed, Amjad. So everybody has said it's an excellent and insightful session. And thank you for introducing to IoT, says Prashant. Okay. And Dattatreya says, thank you for the excellent information. Shashikant says, thank you. And Mohammed says, it is excellent, insightful, and he feels like he's in a class already. So over to you, Girish sir and Jacob sir.
Now I would like to invite our president, PMI Mumbai chapter, Mr. Jacob sir, for giving vote of thanks. I'll be presenting the certificate to you.
Thank you so much, Girish. Thank you, Sonali. And I would like to thank on behalf of the Mumbai chapter and also personally also Dr. Vinaya Gaonkar, an excellent morning session of 2 hours of very high quality technical inputs as far as IoT is concerned. It is a great knowledge sharing session that we had here. I'm speaking from the bottom of my heart. I stayed for the full thing. I heard the full thing. Only thing I missed out, Dr. Vinay, is that where are you? You are in Pune based, and where are you?
Yes, I'm in Pune. I'm working in MIT World Peace University, presently heading School of Electronics and Communication Engineering.
Oh, wow, wow, wow. So that is why you have such a lot of technical and beautiful. It was an excellent session that we had. We should be hearing more about you in the days to come and your interactions with Project Management Institute Mumbai chapter. So 80 plus participants were there, and all of them were there till the end. That is a great thing. So thank you very much on our behalf, and it's a great time that we had. So thank you very much, Dr. Vinaya. I'd just like to mention to all the participants here right now who are attending this program that we are having our conference in December. That is not a conference only for the chapter. It is the conference for the entire South Asia. I see a lot of sprinkling of people from across the world here in this group right now. People from Europe, Bangladesh and other places. Thank you very much. Just to remind you, we are having our Mumbai chapter led conference, which is for South Asia, which includes Sri Lanka, Bangladesh, and India, and delegates from all over the world. It is happening on the 9th and 10th of December, and it will be at Worli. It will be Worli in Mumbai at the Nehru Center. So we are going to have a lot of good speakers, excellent speakers, VIP speakers. We'll be having a lot of interactions. Please do register. Things are filling up fast. We have a very big crowd expected there, and you will be having a lot of options to interact with everyone. So all of you present here, request you, it is 9,000 for the registration for 2 days. You have 2 power pack days of information and project management and other related topics. It will be a great place for you to interact with others also. So thank you very much, Vinay, once again. Dr. Vinay, thank you, and all the best. Have a great Sunday afternoon. Thank you.
Yes, thanks a lot. Thanks for giving the opportunity. I also enjoyed the session a lot.
Thank you, Vinaya. Thank you, Girish sir. Thank you, Jacob sir. Thank you, Sunil.
Thank you. Vinay madam, you will be receiving certificate.